So, good morning, everyone. Today we are starting this new topic, which is hydrolysis of salt and buffer solution. Okay, so I think that we will be covering hydrolysis of salts only. We won't be covering buffer solution for today's class. Okay, now I hope all of you revised what we have studied in last class, right? Which was the basics of or the analysis of weak acid, weak base, strong acid, strong base, and all those things, right? Along with common and effect. Okay, everyone. So let's have a small recall test. Okay, let's have a small recall test on what we have studied in last class. Now tell me, the value of Ka is dash as the strength of acid and base. Everyone? Yes. Okay. Okay. Second. So most of you say increases. Okay. Second, if K is the ionization constant of weak acid and Kb is ionization constant for weak base, right? Conjugate base. See, it is written conjugate base. Then pKa plus pKb is equal to what? Tell me, everyone. pK plus pKb is equal to what? Very good, Anisha. Yes, very good. Okay, next, third one. As Kb increases, pH, tell me. Very good, everyone. Okay, so most of you, I'm getting multiple answers. I'm getting multiple answers here, right? Just think about it. Just think about it. Kb increases, right? Means concentration of OH increases, right? Which means concentration of H plus decreases, right? Right, everyone? Which means pH, tell me, think about it, right? Okay, so I'm getting multiple answers. Next, fourth one, we will see, let's see the answer, we'll see the answer. Okay, fourth one, as Ka decreases, pOH, based on the same concept, Ka decreases, pOH. Okay, I'm getting multiple answers. Most of you are saying increases. Okay, so most of you are saying increases. Anisha is saying decreases. Okay, okay. Next, fifth one, last one. For conjugate acid base pair, Ka into Kb is equal to 10 to the power minus 4 always. This statement is true or false? Tell me, everyone, this statement is true or false? Okay, Wes? Yes? Okay. Now let's see the answer now, right? Let's see the answer now. Okay, okay, Samya, Anisha. Now let's see the answer, right? So question number one, almost everyone was correct. Question number two, almost everyone was correct. Now these three, many students have difficulty in these three, right? Now just think about it. I gave the hint, right? I hope I have given the hint, right? Now just think about the hint. Okay, just think about the hint that I gave. We know that Kb is directly proportional to concentration of OH? Yes or no? Right? So if Kb increases, OH increases. Now if OH increases, then concentration of H plus will decrease because concentration of OH into concentration of H plus is constant, which is K. Now if concentration of H plus will decrease, then obviously pH will increase. Right, everyone? Right? So it is increase. Okay. Now this is same as this one, right? If Ka decreases, which means concentration of H plus decreases, which means pH increases, right? So pOH, it also should decrease. Okay, so here the answer is wrong. It should decrease, right? Now fifth one, see K into Kb, Ka into Kb is equal to Kw always, right? But Kw always cannot be 10 to the minus 14, right? Because it changes with temperature. Agree, everyone? Agree? Right? That's why it is false, because of this always. Okay? I hope all of you got the concept. Tell me. I hope all of you got the concept. Okay, everyone. Okay, so today we are starting this. Let's see. Just give me 2 minutes. Okay, so the next topic that we are going to study is hydrolysis of salts. Hydrolysis of salts. Now tell me this, right, everyone? Tell me this. What do you mean by hydrolysis? Tell me. What do you mean by hydrolysis? Everyone, think about it and message me. What do you mean by hydrolysis? Or better, how many of you know what is neutralization? Tell me. How many of you what is neutralization? Everyone know about what is neutralization? Right? Is there anyone who doesn't know what is hydrolysis? Is there anyone who doesn't know what is hydrolysis? Okay, very good, everyone. Right, very good. So everyone know what is neutralization. Now think about this. Think about this. When we talk about salts, right? When we talk about salts, I hope everyone is able to see the screen. Tell me, everyone. You guys are able to see the screen? Yes? Okay, very good. Now, when you talk about salts, right, the first thing that you should know, how salts are formed. So if you remember the very basic reaction that we have studied since junior classes, right? Acid plus base gives salt plus water. Right, everyone? This is a very fundamental reaction. Acid plus base gives salt plus water. Anyone have any doubt in this? Yes, very good, Sneha. Very good, Meet. Very good. Now, this is your neutralization reaction. So I can say that neutralization reaction is responsible for the formation of salt. Right, everyone? Right? Okay? Right? Now, think about it. Think about it. If I have to say, okay, if acid and base can give salt and water, what about the reversible reaction? Tell me, what about the reversible reaction? Right? So reversible reaction should also give something like this. Means when we talk about salt and we react with water, right? H2O. Okay, we will react salt with water, H2O. H2O. Should it give acid plus base? Acid plus base? Tell me. Yes or no? Tell me, everyone. Very good, right? So yes, I can say that. But the question here is, can we do for all kind of acid or base, right? So since in previous classes we studied about types of acid and types of base, which is strong acid, weak acid, strong base, and weak base, right? Now, depending on that, we have acid and base, right? Now, think about it. We have strong acid, weak acid, two types of acid. Again, we have base as strong base and weak base. Now tell me, how many kind of salts can be formed? Think about it and let me know. Tell me, everyone, what do you think? How many types of salt can be formed? Tell me. Yes, four. Yes, very good, Pradyuman. Right? Pradyuman, message to host. Okay, messaging to co-host. So you can say that using these combinations, we can have four type of salts, right? First, so it is salt, right? So we have strong acid, strong acid, strong base salt, right? Strong acid, weak base salt, then weak acid, strong base salt, and weak acid and weak base salt. Right, everyone? Right? Anyone have any issues in this? Tell me. I hope everyone is getting this concept. Okay, this is quite easy. Very good. So we have four type of salts, right? So let's see the types of salts. Okay, now when we talk about the types of salts, right? As you said, it is simple salt, normal salt, acidic salt, basic salt, right? Now it depends on two things, right? First, it depends on the respective acid and base which form this kind of salt. And second is the concentration, right? That is also one of the major factor, right? For example, if you take a huge amount of weak acid and very small amount of strong base, can it be a basic salt? Just think about it. Can be a basic salt? Okay, Nidhi, don't worry, we'll take attendance twice. No, so no issues. Okay. No, yes, very good, right? So you cannot say always. So there's a general term, right? In general, when you say that when weak acid and strong base reacts, we will get a basic salt. So in general, we assume that the concentration is almost comparable. Okay, right? So till class 10th, whenever we said, okay, this is a salt of weak acid, weak base, so it will be basic salt, acidic salt. So we have assumed that the concentration is more or less same. Okay, right, everyone? But when we talk about numericals, right, when we talk about numericals, we have to take this concentration factor into consideration. Okay, everyone, right? Okay. Now, as we said, the classification of salts. So what we are going to deal with, we are going to deal with only these three kinds, right? There are many other type of salts like double salt, addition salt, and all those things, right? But for us, we have to deal with, right? First kind of simple salts, which is normal salt. Now, when we talk about normal salts, see, these are the normal salts, right? So if you see this, right? If you see this, okay, so mostly normal salts are your strong acid and strong base salts, right? Now, how can you say that it is strong acid and usually strong acid? Okay, now take example of NaCl. NaCl. Now, always look for cation and anion. So in this case, cation is Na plus and anion is Cl minus. Now, whatever cation or anion you'll get, right? Now just think about this, right? Add OH because a base will give OH minus, right? So this Na plus, right, should have been formed by a base NaOH. Tell me yes or no, because this NaOH will give OH minus, then then we will get Na plus, right everyone? Tell me. Okay, now when we talk about this Cl minus, this Cl minus is a conjugate base of an acid which is HCl, right? Now think about it, this NaOH and HCl, what kind of acid or base they are, right? They are strong base and strong acid, right everyone? Right? Yes. Okay, right. So when we talk about normal salts, which is basically a neutral salts, right? So they are the salts of generally strong acid, strong base of comparable concentration. Okay, right? Okay. Now acidic salt, basic salt, suppose take example of NaHCO3. So Na plus HCO3 minus. So Na plus will be formed by NaOH, which is a strong base, and HCO3 is formed by H2CO3, which is weak acid. Now, if they are taken in comparable concentration, what do you think? Strong base and weak acid, right? So obviously it will be, tell me, right? So it is like it's wrong, basically it's opposite. Okay, everyone? Okay, right everyone? Yeah, basic, it is opposite, because just take example of this now. Just take example of this other one, right? So in other one, it will be forming using ZnOH whole twice, right? The base will be ZnOH whole twice and HCl. So HCl is strong acid, right everyone? Okay. Now, this was your normal salt. Double salts of the salts, right? Double salts of the salts that will be formed when we have two kind of salt, okay, in a simple compound, in a same compound, right everyone? Now we won't be studying about these, okay. For now we'll be studying this in the other chapter, which is chemical this coordination compound. Okay, so about double salt and complex salt we will be studying in other chapter, not this chapter. Okay everyone. Now, next topic, right? As we started with this topic, which is hydrolysis of salt, right? Hydrolysis of salt. Now, when we talk about hydrolysis of salt, okay. Now, what do you think? Tell me, what do you think? What is the meaning of hydrolysis of salt? As I said, right? Hydrolysis is a reversible reaction for neutralization reaction. Yes, everyone. Hydrolysis is a reversible reaction for neutralization reaction. Yes. Okay. Now, if hydrolysis is a reversible reaction of neutralization reaction, it means the salts will react with water to form acid and base. Okay, right? The salts will react with water to form acid and base. Now, my question is, can all type of salt will react with water to form acid and base? Tell me, can all type of salt react with water to form acid and base? Let's take example of this one, fourth one, right? Salt of strong acid and strong base. Can they hydrolyze? Tell me about it. Salt of strong acid and strong base. Can they hydrolyze? Yes or no? Everyone, please let me know. Yes, very good, right? Very good, everyone. No, because now if some of you might be wondering why not, just think about this. Just think about this. If we talk about NaOH, right? If we talk about NaOH, it breaks down into iron into Na plus OH minus. Now tell me, is it possible for Na plus and OH minus to recombine and form NaOH? Tell me. Yes or no? Yes or no? No, right? Because that is the basic definition of strong acid, strong base, right? That reversible reaction does not happen. Okay. So when you talk about Na plus and OH minus, right, to react, or Na plus and Cl minus to react with H2O, Na plus will not react with OH minus to form NaOH. Okay. And Cl minus will not react with H plus to form HCl. It will never happen. Okay, everyone. So that's why when we talk about hydrolysis, it occurs only for weak components. Right, everyone? Okay, right, everyone? Now let's see this. We have discussed that we have 4 types of salts. Now we will start with the last one. Strong acid, strong base. No hydrolysis. Agree, everyone? No hydrolysis. Okay, very good. Now, salt of weak acid and weak base, right? Hydrolysis will occur. Agree? Hydrolysis will occur. Now tell me, hydrolysis will occur of what? Because obviously we have two different ions. One cation, which is from base, one anion, which is from acid. So hydrolysis of which component will occur here? Acid component or base component? Cation or anion or both? Tell me. Yes, very good, right? Very good, Sneha. So hydrolysis of both, right? Anionic as well as cationic ions will occur, right? Hydrolysis of both. Now, when we talk about salt of strong acid and weak base, now tell me, in this case, right, which component will undergo hydrolysis? Tell me, which component will undergo hydrolysis? Wait, everyone. So, in this case, right, obviously weak base will undergo hydrolysis. Salt of weak base, right? Basic component. Yes, very good, right? So I can say that hydrolysis, right? You have to understand first, again, if you understood the reaction, right, then everything is chemical equilibrium. That's what we will see, right? Hydrolysis of weak base only, right? Okay. Now, when we talk about weak acid and strong base, again, hydrolysis of weak acid only. Now, everyone got this concept? Tell me, everyone got this concept? Yes or no? Because you should keep asking, right? This problem, okay? You should keep asking yourself which component, right? What we have to do with each component. That's why I'm telling you in step by step. Okay, everyone is clear? Anjali, Tulip, Sania, Samya, everyone, Vivek, Akshaya, Anisha, Chulika, very good. Koshi, Khushi, this concept is clear. Anamika, Ria, okay. Siddharth, Shreya, Sania, yes. Very good. Because this is the most important concept. This is the most important concept. Apart from this, everything else is your chemical equilibrium, right? Okay. Now let's see. So we will start with the first one, which is salt of weak acid and strong base. Now, as I said, we should have comparable concentration? Yes or no? Tell me. Yes or no? Because suppose I give you lots of strong base, what will happen? If I give you lots of strong base, right? I give you lots of strong base, then it will utilize your acid and the amount of salt will be very small, right? Okay, the amount of salt will be very small. Okay, right? So see, you can argue on many things. Why not this concentration? Why not that concentration? But the type of reaction or the reaction will what the reaction will occur depends on concentration also, not only on the type of reactant. Okay, for example, when you talk about strong acid, strong base, it can either be acidic solution or basic solution or neutral solution, depending on the concentration that we have already studied in last class, right everyone? If you have more of strong acid as compared to strong base, okay, more of strong acid as compared to strong base, we can get acidic solution. If we have more of strong base, we'll get basic solution. If we have equal concentration, then we will get neutral solution. So we cannot say hard and fast, right? So when we're talking about any of these, we are considering, right, equal amount, equivalent amount, right? So see this. This is one of the most important factors that we will be assuming for every derivation that we make. Okay, now, so let's see, we will just take one reaction. Okay, we'll try to solve it by ourselves. Okay, first we'll try to solve it by ourselves. Everyone, you should try. Okay, take out your notebook and try to solve. So the first is hydrolysis. Everyone should try to solve by yourself, because if you try to solve by yourself, you will get to know what are the concepts involved, right? And you will get to know why you don't have to remember any formulas. Because one of the major issues with everyone, okay, who study Ionic Equilibrium, Chemical Equilibrium and feel that it is difficult because they don't understand the underlying concepts. And for me, these two chapters are one of the most easy chapter because everything is linked and you don't have to remember. Okay, if you know the concept, if you know how to derive things, you don't have to remember. Okay, so hydrolysis of salt of weak acid and strong base, and strong base, right? Not, let's see, weak acid I'm taking as acetic acid, which is CH3COOH. Strong base I'm taking as NaOH, right? Now, this is your CH3COO minus Na plus H2O. Now, this is your salt, right everyone? Okay, agree? Now, I'm not saying you to make this reaction as reversible, okay, because it won't be reversible. Okay, now the reaction that I'm concerned with is this one, right? CH3 COO minus, right, Na plus H2O gives what? Now Na plus here is useless because Na plus will be in same Na plus form, right everyone? Yes or no? Tell me, right? Because it will not recombine with OH minus to form NaOH. So if you not write this Na plus, still it is fine. Now this reaction is reversible. This reaction is reversible, and here, right, we will get what? It will, this CH3CO minus, this is the component of weak acid. Sorry, weak acid, and this is the component of strong base. So it will again combine with H plus to form CH3COOH plus OH minus, right? Again Na plus, right? So I can just, okay, you can just write Na plus as it is, but we will be ignoring this Na plus, right everyone? Anyone have any issues? Tell me, anyone have any issues till this point? Because I told you, right, whenever we talk about equilibrium, the first step, write the reaction. So anyone have any issue with the reaction? And me, please write the name of the boys who are absent. Because many boys are absent from past 2-3 days. Okay, now second step, initial concentration. So C, right? Initial concentration C. Now H2O, again H2O will be in excess, so we won't be taking the concentration of H2O. Here it will be 0, 0, because Na plus, we won't be worrying about Na plus. Okay, we have only 36 students present, which means at least 9 students absent. Okay, so at equilibrium we will have C minus C. Now here hydrolysis, for hydrolysis we are using a constant called as H. Okay, right? H, hydrolysis constant. So instead of alpha we are using H. Okay everyone, right? Just notation has changed. Okay, because this is not your dissociation reaction, this is your hydrolysis reaction. So instead of alpha I'm using H, so it will be CH, right? Now we know that Kc, but since it is a hydrolysis reaction we will tell it as KH. Okay everyone, right? KH. Now this is equal to what? Now let's write it. Concentration of CH3 COOH into concentration of OH minus divided by concentration of CH3 COO minus. Agree everyone? Which is equal to CH square by 1 minus H. Agree everyone? Anyone have any issue till this point? Tell me. Anyone have any issue till this point? Step by step. Now, don't you think that we are doing the same thing that we have been doing for weak acid, weak base, or all the questions in chemical equilibrium? Right? Right, everyone? So what is the issue here? What is the issue here? The issue here is in all the questions that we have discussed so far, we knew the value of concentration C, we knew the value of Ka or Kb, right? But here we have Kh, right? And the value of Kh we don't know. That's the key point here. The value of Kh we don't know. We just know the value of these three, Ka, Kb or Kw, right? We just know the value of these three for any acid or base. Value of KH we don't know, right? So what should be our next step? Tell me. Till this step, it is same as chemical equilibrium. Now tell me, what should be my next step? Everyone think about it and let me know. What do you think? What does your intuition says? What should be my next step? We don't know KH, right? We don't know KH. Okay, let me ask you this. Here, right, apart from salt, what other component is being formed? Tell me, what other component is being formed, or what other component can you see here? Can you see weak acid here? Tell me, can you see weak acid here? Yes or no? Tell me, can you see weak acid here? Guys, please reply. Am I audible? Right? Yes, Meet. So weak acid, and this reaction is reversible also, right? This reaction is reversible also. So I can say that we have this reaction also. CH3 COOH is also, right, breaking into CH3 COO minus plus H plus, because this is a reversible reaction also, right? And for this reaction, Ka is equal to concentration of CH3 COO minus into concentration of H plus divided by concentration of CH3 COOH. Tell me, yes or no? Yes or no? Everyone, yes or no? So let's consider this is equation number A and this is equation number B. Right, everyone? everyone? Tell me, right? So let's rearrange this equation a bit, right? Can I write it like this? Concentration of CH3 COOH divided by concentration of CH3 COO minus is equal to what? Concentration of H plus divided by K. Anyone have any issue till this point? Tell me. Anyone have any issue till this point? It is Ka, not K9. Tell me, everyone. If you don't have any issue till this point, please raise your hand. Everyone should raise your hand. Everyone is getting the concept step by step. If you have any issue at any point of time, at any steps, please ask, right? Okay, I'm trying to make you understand as simple as possible. Okay, very good. Everyone is getting very good, everyone. Now, can we use this from equation B to equation A? Because see, both of them are same reaction. Yes or no? Both of them are same reaction. So concentration of CH3COH and concentration of CH3CO minus would be same, right? So let's use B and A. So I can write it like this: KH is equal to concentration of H plus into concentration of OH minus divided by Ka. Agree? Because I just replaced this one, right? Now, do you think that we can use something else over here? Tell me. Can you see here something? Everyone, can you see here something? What is concentration of H plus into concentration of OH minus, everyone? What it is called? Tell me what it is called. Yes, very good, everyone. Very good, Samya. Very good, Ronak. Very good, Anisha. So this is KW by KA. Very good, Sanya. Now, don't you think that we know KW already? Yes or no? We know KW already, and we know the value of Ka also, right? So even though we don't know KH, but KH can be written in form of Ka, KW, KB. Agree, everyone? Right? Agree? So from here we got KW is equal to, sorry, KW by Ka is equal to KH. Okay, right, everyone? Anyone have any issues? Now let's go back to our this expression, right? Let's go back to our this expression. Which expression? Right? The expression that we already have. KH is equal to CH square. Why? Because H very less than 1. If, right? If H is very less than 1, then KH is equal to CH square. Now don't you remember something? Right? This is the exactly same thing that we did with weak acid, weak base. Yes? Tell me yes. Right? So H is equal to root of KH by C. Right? And we know that concentration of OH minus, because OH minus furnished over here, right, everyone, is CH. Same as weak acid, right? When we talk about the method, it is same as weak acid, which is root of KH into C. Right, everyone? Right? So if you say POH, it is exactly the same that we have done in, tell me, pKh minus log C. Agree, everyone? Tell me, agree till this point? Agree? Don't you think that we are doing same thing that we did for weak acid, weak base? Okay, right? But we don't know the value of KH. We have to convert pKh into KW and KH. So we know that. Let's see. pKh, right? Or just think about it, right, everyone? Just think about it, right? I'll just use this portion of the screen, okay, to find. So we know that pKh is equal to minus log KH, right, is equal to minus log KW by KA. Now, log A by B is equal to what? Tell me, log A by B is equal to what? Log A minus log B, right everyone? Right everyone? So it is minus log KW minus log KA. Okay, so we put minus inside, so we will get what? Minus log KW minus log Ka. Now what is minus log KW? Minus log KW is pKW minus log Ka is pKa. So pKh is equal to pKw minus pKa. Yes or no? Yes or no? See, I'm so horrible at drawing straight lines. No wonder I can never draw anything. Right, everyone? Okay. So if you see, if you put the value over here, right? If you put the value over here, so what we will get? We will get half pKh is equal to pKw minus pKa minus log C. Anyone have any issue till this point? Tell me, anyone have any issue till this point? Yes or no? Yes or no? Step by step. Okay. Now this is POH. This is POH. What about pH? So we know that pH is equal to 14, which is nothing but pKw minus POH. Yes or no? Right? So which is pKw minus this whole thing, half pKw minus pKa minus log C. So if you simplify it, 1 minus half is half, right? Okay, or 14 minus 7 is 7, right? Minus, now take minus at every outside, so minus minus plus half pKa plus log C. pH is equal to. Anyone have any issues? Tell me, anyone have any issues? So this is the formula of pH for what? Hydrolysis of salt, of weak acid and strong base. Everyone got this concept? Tell me, everyone, take your time. I'm giving you 2 minutes. Okay. Okay. Very good, everyone. So I hope all of you got it, right, everyone? Now so this is first type of salt. Okay, first type of salt. Now let's think about second type of salt, right? I hope everyone is understanding this concept, right? Now, second type of salt. Now this you have to do for now, right? Then I'll explain second type of salt, which is salt of weak base and strong acid strong acid. So I'll give you salt. The name of salt is NH4Cl. Okay, NH4Cl, right? So everyone, please try to find the pH for this one. So NH4 plus Cl minus plus H2O gives what? Right? Gives NH4OH plus H plus, right? Okay, step by step, try to solve each and everything. Okay, I'm giving you 5 minutes. Try to solve it by recording this. My bad, sorry. Okay, so I have to explain this again. Okay, you guys think, till then I'll just speak it again for the students who might have missed it. So we have salt of weak acid and weak base. Okay, so we will take this component, right, of weak acid and from weak base, and both of them will hydrolyze to form acid and base. Okay, so we'll write the same reaction, right? C minus CH, C minus CH, 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 then KH as per your chemical equilibrium, right? Now I can say that this concentration CH3COOH by CH3CO minus, right, can be written as concentration of H plus by Ka, as we have seen in weak acid. Okay, in same way, concentration of H4OH by concentration of H4 plus can be written as concentration of OH minus by Kb, as we have seen in the concept that we have discussed in weak base. Okay, using these two, I can just say KH is equal to concentration of H plus by Ka into concentration of OH minus by Kb, which is Kw by K into Kb, right? Now my next question was how to find pH. Okay, so obviously I cannot find pH from here, right? I cannot find pH from here. How to do that? Now think about it, right? Just think about it. We know that we have an acid over here, which is CH3COOH. Now this will give CH3COO minus plus H plus, right everyone? Tell me, right? Yes or no? So I can say that Ka is equal to concentration of CH3COOH, sorry, CO minus, right, into concentration of H plus divided by CH3COOH. Right everyone? Tell me, right? Tell me yes or no? Yes or no? And from here I can say that it is H squared. So from this equation, right, I know that H is equal to root KH. Yes or no? Tell me, agree? Right? Agree everyone? Right? Now think about it. Think about it. How to find pH? I've given you enough hint, everyone. Please think. I'm waiting for the answers, everyone. Okay, let's see, right? I hope someone might have figured this out, right? So see this, right? This is something which I have said. And what is the concentration of CH3CO minus? From here, the concentration of CH3CO minus is C minus CH. Write it down. C minus CH. Divided by concentration of CH3COH is CH, right? Into concentration of H plus, which we need to find. Okay, everyone. So can I say that concentration of H plus is equal to CC will get cancelled and it is 1 minus H. So it will be just 1. So can I say that concentration of H plus is equal to Ka into H? Agree? Tell me, agree? Yes or no? Yes or no? Even if you don't, right? This is whole square, by the way, right? This is whole square. Even if you don't assume that H is very less than 1, right? Even though it will be H by 1 minus H is equal to root of KH. Okay, and here we will get H by 1 minus H. So everything will be same. Okay, everything will be same. So it will be Ka into root of KH. Agree everyone? Tell me. Agree till this point? Anyone have any doubt till this point? Think about it. Think about it everyone. Samya, Chulika, Anjali, are you getting the concept here? Yes or no? Because here it is weak acid and weak base, right? Everyone, please let me know. Please let me know everyone. So it is Ka into, now we know that root KH is equal to root KW by Ka into Kb. Right everyone? So if you see this, we will get concentration of H plus is equal to root Kw into Ka by Kb. So if you take log and all, right? If you take log and all, so we will get log minus log concentration of H plus is equal to minus half log Kw plus log Ka minus log Kb. Right everyone? Right? Step by step. So we will get pH is equal to half pKw plus, sorry, this is pKa, because minus, right? Minus pKb. Tell me, got it everyone? Step by step, got it? Yes or no? Yes or no? Take your time. Okay, you can just prove it once again at your home, right? Right everyone? So these are the formulas for pH. So if you recall, right, write down all the pH formulas. Let's write down all the pH formulas. So, right, we still have a buffer solution. Okay, so there's one more type of salt which is there. Now this is a mixture of salts, right? This is a mixture of acid and salt. Okay, so let's write down step by step. So first, pH of weak acid, just weak acid, okay, is equal to what? Tell me. Half pKa minus log C, right? pH of weak base is equal to what? Tell me. 14, because POH was this. So it is 14 minus half pKb minus log C. Right everyone? Because POH was half pKb minus log C. Then this is 1, this is 2, 3. pH of salt of weak acid and strong base. What was the formula? pH was 7 plus half pKa, because weak acid pK, remember like this, weak acid pK plus log C, right? Fourth, pH, see I'm saying just pH of salt of strong acid and weak base is equal to, again, pH is equal to 7 minus half. Now weak base, so we will get pKb plus log C, right? Fifth one, pH of weak acid and weak base. So again, pH is equal to, now this one, it will be half pKw plus pKa minus pKb. So if you just divide it, it will be 7 plus half pKa minus pKb. Got it, everyone? Tell me, got it? Yes or no? Yes or no? And if you see this, it is also half pKh minus log C, right? This is also, right? 14 minus half, okay? So everyone got the concept till today's? Tell me, everyone got the concept? Yes or no? So hydrolysis of salt, we are done with hydrolysis of salt. I hope everyone understood each and every concept of hydrolysis of salt. Okay, so on next class, most probably Wednesday, right? Or sorry, Wednesday only, we will try to solve the problems on hydrolysis. Okay. Right, everyone? Tell me, right? Okay. Now let's see some concept test. Hey, this one we'll solve later. Okay. Yeah, this one. Everyone try to solve this one, this concept test. Tell me, what's the answer, everyone? Okay, Nishita, very good. Yes, you got the concept, Nishita. Very good, Nishita. Everyone else, this is very important concept. Very important, very easy concept. See, this is the first thing that I told you. This is the first thing that I told you in today's class. Now, the answer is right. A. Why? See this. Hydrolysis constant. Okay. The answer should be B. Okay. The answer should be B. Guys, this answer should be B. Okay. So we'll see each other on Wednesday. Okay. Bye, everyone. Bye, everyone. Thank you, everyone. Thank you, everyone. Take care. Bye, everyone. Bye, bye.